This video is going to cover the basics of WebDriver, moving from a very simple test to adding some synchronization, to creating some page objects, to using JUnit effectively as an execution framework. And at the end of this, you'll have seen how locators work, how to manipulate the page, how to synchronize the page, the real basic fundamental building blocks of working with Selenium WebDriver and Java. So I do have a project on GitHub, which covers the type of concepts that we're going to go through in this video. It's called Start Using Selenium WebDriver, so github.com/EvilTester/start using Selenium WebDriver, and you can download all the code from there. But rather than go through the code and talk about it, I'm going to create the test from scratch again and refine it in different steps so we can see it in action. So I'm assuming that you have an IDE installed, you have Java SDK, and you have Maven installed or Gradle, whatever you want to use, because I'm not covering the basics of Java. I'm going to cover the basics of Selenium WebDriver. And as an example page, I'm going to use this basic web page on the test pages application. It has 2 paragraphs of text, which we can interrogate. We can locate them, interrogate them, see the text that's in there. We've got a button again, which we can locate and interrogate, see what the text is. We can click it so we can manipulate it. And then a message is displayed, which we have to synchronize on. So that's going to be our basic framework for testing here. So I'm just going to create a new test here and we'll call it YouTube video test. Now the first test you're ever likely to do with WebDriver is going to be very basic. We'll have an @test, we'll give it a name. We're going to use JUnit as the test execution framework, and we're just going to put all our code in here. Now our first test is going to use WebDriver directly in the test. So I'll create a WebDriver, and then I'll need to go to this page. So I'll get the URL for this page. So what we've got so far is we've got a WebDriver instance. We're going to get the page, and then I'll just close it. Let's do that. Driver.quit. This is the most basic WebDriver test we could possibly do. Let's run it. There we go. What happened? So with WebDriver, we have to create a WebDriver. Typically in your test, you'll use the WebDriver interface. We have to instantiate WebDriver as a particular type of browser. So here I'm using the Chrome driver, which will bring up a Chromium browser. When I do this, WebDriver will download the browser and drivers that it needs to run with, which means that when you're putting this into continuous integration, you don't have to install a driver or install a browser. You basically just use WebDriver, it will download it. This makes it very easy to use. In order to access a page, we do driver.get and then the URL for the page, and then we quit. There's 2 ways of closing down WebDriver. Driver.close, which closes the current tab, driver.quit, which closes the entire browser and driver down. Typically, I'll just use driver.quit. So that's our basic how do I use WebDriver. Now what I want to do is I want to locate things on the page. So I want to locate this text, a paragraph of text. So let me inspect this. So we're lucky. This page, we've got an ID for para 1, so let's just use that. So I will say driver.find element. Now you can see I could find element or I could find elements. I could find the paragraphs with certain classes. I could find a whole bunch of stuff. But I just want the one thing. I just want to find the element. And then when we're working with WebDriver, we have to give it the location strategy, which is the by operator. And you can see with by, we've got static methods there. We can use CSS selector, tag name. We can use ID, which I'm going to use. We could use name, class name, link text. Typically, a lot of time I'll work with ID or class name, or I'll be using a CSS selector most of the time. The others I don't tend to use very much. And I could get away with simply using CSS selector or XPath because everything else will delegate down to those anyway. So let's use an ID. And I want the ID from the DevTools, which is para 1. So this will locate the paragraph on the page. I can't do anything with it because I haven't saved it. So let's put that into a variable. And you can see that what we've got is a web element. So with WebDriver, we've got the interface for the WebDriver itself. This allows us to do things like find elements, quit, switch to frames, switch to tabs, get information about the current browser like the URL, source, handles. Driver is the top level that we work with, then web element is the lower level, which is the thing on the page. So what we've learned how to do at this point is we've learned how to locate items on the page, how to find things on the page. So now that I've got an element, I can interrogate it. So with the element, I can get the text. I could get attributes. I could even use it as a base to then find children with find elements or find element below this, and it would start at this particular element that I found. So it allows us to work through the structure of the page. But here, all I'm going to do is get text. So I'm going to interrogate the element once I've located it. So what I'll do is I'll stick an assertion in here. So JUnit assertions dot assert equals, and we'll take the text, which is a paragraph of text, and check that it matches. All right, nothing complicated there. Let's run this. We're expecting it to pass. And it did. So nothing hard there, but we've covered some basic principles. We've covered how to start up and shut down a driver. We code against the interfaces, remember. We've figured out how to locate an item on the page, and we've learned how to interrogate it using the methods on that element. Now, this is horrible. One of the issues that we've got when we see examples online is that they're so basic that if we copied this, and you will see tests like this in the real world where people are creating drivers and closing them down in there, because that's the example they've learned from. So the immediate next step we're going to do is make this a little bit better. One of the issues we face is if the test fails, we haven't closed the driver, so the browser is still going to be active. So we can fix that, and we'll fix that using the test execution framework that we're using. In this case, it's JUnit. So I am going to want to, after all the tests have finished, I'm just going to say tear down, and in there we'll put the driver.quit. Now, in order for this to work, I need to obviously create the driver in a static context. So before all of the tests have happened, let's move the driver in here. Now, obviously, this needs to be created outside the static context. So now we have got a driver that's static to this class, so it can be set up in the app before all. Then we've got a test. Now, one of the things I might want to do is not have the driver.get in the test. I'll move that into an at before each. We only have one test here, but it's highly likely that if there were more tests in here, I go to page, and then we'll instantiate this. Right, so now we've got something which is a bit more production ready. This is more like what we should be writing. Still not good enough for production level test code, but it's a much better example to learn from. So what we've got here, let's run the test, make sure it still works. Yep, wasn't expecting anything to go wrong. So a couple of concepts. We're using the test execution framework, which is JUnit, to make our tests more robust in terms of the execution process. So we're going to create a WebDriver such that it can be used across all the tests that we have in this class. We're going to reset the state of the application before any of the tests run, which we're doing here. When I do driver.get, it will refresh the page, it will reload the page in the browser, so everything will be back to normal, and we start from scratch. In the after all, when all the tests have finished, regardless of what state they were in, we will quit the driver and close it down. So now if the test fails, we still tidy up after ourselves. If we add more tests, they will start from a clean start point because we're getting the page each time. So it's a little bit cleaner. And you can see our test now has very little in it. We're just locating the element, then interrogating it and asserting on it. That's better. If, by the way, you ever see any examples that are using main as the driver for your tests, block that out of your mind and immediately put it into a JUnit or TestNG framework, because this is how we want to write our tests. One of the issues with learning from examples on YouTube like this is you will copy us, and you will copy putting everything in a test method. You will copy this, and your test will be filled with driver.findElement, which we don't want, because we want our test to be more maintainable. And that's what we're going to do next. So that brings us on to the concept of abstractions. I'm not going to do any abstractions for the driver, but I am going to do an abstraction here. Typically with an application, we are going to want to work on multiple sites. We're going to want to work locally. Here I'm testing the production site, test pages. I could easily run this locally, in which case I would want to change the domain that I'm running against, because I don't want to run against test pages. I want to run against localhost. So what I'm going to do is I'm going to refactor this out, and I'll just call it, I'll call it env dot, in fact, that's not necessarily a good name. Let's call it test env and domain and plus. So let's create a class for this. So now we've got a class, and I want to create this as a static field, and let me put in here https:// testpages.eviltester.com. Right, so now I've abstracted away this information. So our test now has the page that we want. If I want to run this against localhost, I could amend this to be a different value, or I could amend this to be a method, which then uses an environment variable to then tell me which domain I'm working on. But we're changing the test to make it more maintainable. But this is still a little bit too focused on the test itself. What I really want is a page concept. So we do have in general automated terminology the concept of a page object, an object that represents a page or a component in the application. So for us, that's going to be quite easy. So I'm going to call it basic page at the moment. New basic page. I'll want to instantiate that with the driver, because we're going to move this. We're going to give the page itself the responsibility for opening itself. Sometimes I don't do that. I create a navigation class, but for this current example, I'll delegate the responsibility to the page. All right, well, let's just create these. Create class basic page. We want this to be stored. So we'll create that as a field in this class. This class isn't going to be particularly big. So then I'm going to want to say page.get. I'm not going to tell it what to get because it already knows what it's going to do. So let's take this code and put it in the page.get. Now what this has done is our test is not as physically tied to the page as it was. If we change the URLs in our application, I should only have to change this in one place now, change it in the page, rather than all of the tests that are working with this page or all the test classes that are using this page. So this is a way of making our tests a little bit more maintainable, a little bit more robust when the application changes. But we still have items in here that are directly using the driver, and they don't need to be because they're accessing a fairly common part of the page. So I want to move this into that page. So there's multiple ways of doing this. I'm going to do the simplest at the moment. Page.get para text. And that will run and locate the item and get the text back. I'm going to go to the real extreme of a page object at this point. And we don't necessarily always need to do that, but that's what we'll have a look at this time. So why is that red? Because I've instantiated this in here. So let's take this out. Right. So this doesn't exist. So let's just copy this. So get para text is going to be an abstraction which will locate the element or find the element using a locator and get text. Now we could argue whether this is the right thing to do, but what I'm trying to demonstrate here is that we build the abstractions that we need for the test at the moment. We don't build a whole bunch of abstractions because we will need them in the future. We build what we need now. So now the test is ridiculously simple. Now the issue with this is it isn't a great example of a test. It's not a great functional test. And really it's testing content, which is not always the best thing to do, but at least we are abstracting something on the page. The something on the page is the paragraph. We're not in here saying page dot is paragraph 1 shown correctly. What we're doing is we're saying we'll get the text for the paragraph 1 and we'll assert it. So the test is doing the assertion for us, and the page object is doing the work for us for how we get this information. All right, so that's the basics of page objects. Page objects are simply abstractions, classes, which hide information from the test. What they also do is they make it easier to write future tests. So in the future, when we've expanded this out, most of the work I do will do page dot, click the button, page dot is the success message shown, and there will be less driver usage inside the actual test. Now, what some people will do is rather than instantiate the driver here in the app before all, they would create a base page and the driver would be instantiated in that, and then it'll be available to anyone. I'm not going to do that. I typically don't create a lot of base pages, so I won't demonstrate that. At the point that you need it, then that's when you'll use it. So we've got a very simple test here, and this is a much better representation of what your first WebDriver test should be. We're starting to use page objects, and we're using the JUnit execution features to make the test more robust. But the next thing we really want to do then is have some sort of functional test. So let's create a second test. My second test. All right, so let's have a quick look here at the actual page. So there's no point really checking another paragraph of text. For completeness, I might want to do that, but it's just another structural locate, interrogate, assert. What's interesting is that we can locate the button, click it to manipulate it or interact with it, and then we've got a message that's shown here, which we can then assert on. Let me just quickly check to see what's happening in the DOM when we do that. So I can see that we have the button one, which is an ID, which will make it easy to locate. It's got text I could assert on if I really wanted. I can see that we've got this message. Click me, message, details are shown. So this is always there. This is always in the DOM. So when I click this, I have to wait until this paragraph has the text, not wait till the paragraph is shown, because it's always shown, it's just empty. Let me see if I edit this as HTML. There's no styling on there. Whenever there's a value in there, it's shown on the page. So I have to synchronize on this page on the value, the text that's in there, not the element itself. So let's start by clicking the button and make sure the item is shown. So my second test, let's call it can click button. So what I'm going to want to do is I'm going to want to say page dot, and I'll call it click me button. Now that's a very structural name, but it doesn't matter because it's just a name in here and we can refactor it later if the page ever changes. And what I'm going to say is click me button, click. So none of this code exists yet. So let's Alt Enter to create it. But we can see because I put a dot click after it, it knows we're pretty much returning a web element. So I need to return the web element. So driver dot find element by ID. What was it called? It was called click message. Copy that ID in here, and that will return. So very often we don't do this. Very often we hide the clicking inside the page object itself. Now it really depends on your usage of what kind of automating you're going to do, and you'll make that decision as you work on it. But for me at the moment with the test that I'm writing, this seems like the easiest thing to do. So click button, click. Then I will want to assert on the message. So let's just do that in here very quickly. So let's do page.get success message, which is the click message. So hopefully you've noticed a deliberate mistake. This test wouldn't work because I put click message in here, but it's in the abstraction. I only have to change it once. Button 1, which represents the button 1 there. Easy fix. So if I'd broken the test and run it, this is why we want page objects. We only change the information in one place. So get success message. Let's create that. So that'll just return the string at the moment. Driver.find element by ID. And that's where we want the click message. Oh, so click message. Let's return the text. Now this will change because I'm just building this up as we go through. And so it says you clicked the button. Can I copy that in time? I don't think I did. So let's put this in the assertion. You clicked the button, exclamation mark. Any capitals, you clicked the button. All right. So this should hopefully work. Let's see. So we've used the page object to return the click me button, then we're clicking on it, then we're asserting. So that worked. At this point in time, the message is there in the DOM fast enough that our test handled it. But there's a risk. I think there's a risk that if we introduce a message to the server for the success of this, that the message might not be there quick enough. So I really want to wait for that. I want to synchronize. One of the key concepts that we have when we're automating is that we need to master synchronization. And WebDriver makes it quite easy to do that. So I want to wait until this is there. So I'm going to say new WebDriverWait. There's a built-in class in WebDriver. So we give it the driver, we give it a duration. This is the duration that we would maximally wait for the condition to happen. And I could go straight in and say wait until, but what I'm going to do is I'm going to put this into a variable because this can make our test a little bit more readable. And what you'll find is that if you have a test class, very often it needs the same duration on the wait, and we'd move this wait up here into the at before all or the at before each, and we'd create our synchronization basis at the top. But here I will say wait.until. Now, this will take a function to check that the condition that we want to wait for has actually happened or not. And WebDriver has an easy way of handling this because it has a lot of expected conditions built in. Expected conditions. So this is a class which has a lot of static methods. So I want to wait until the expected condition text to be in the particular element. So let's say I want a text waiter, and I'm going to say text to be present in element value. So this will take either a locator or a web element. Now, I want those to be in the page. At the moment, you can see that we've got page.getSuccessMessage, which locates the message on the page and then returns the text of it. So what I could do is change getSuccessMessage dot get text and change this getSuccessMessage to return the web element rather than the text. So now I can actually use that in here. Text to be present in element page.getSuccessMessage. And what text do I want to be present? Well, I'm waiting for the success message, so let's try that. All right, so this should click the button, wait for the message to be there, and then assert that that's the message. So let's run this test. Click the button. So it's waiting 10 seconds, which means it didn't find that. Okay, you can see here it says text to be present in element value. There's no value in that paragraph. What I want is text to be present in element, not the element value. Element value would be a number input field or a text input field. What we want is text to be present in the element. So this should pass. In the same way that we do get text here, I'm not doing get value or get attribute value, I'm doing get text. We want text to be present. So it's very important when you are using the expected conditions. Let me just quickly show you this. I'm going to click through into here. Now, the first time you do this, we're clicking through into the WebDriver code. So I'll say download sources. It's very important that you understand what your expected condition is doing under the covers. So here, text to be present in element, we are doing the function. This is how you will learn how to create expected conditions, by the way. They'll all follow this kind of format. So we can see that we're getting the text, and then we're checking text contains text. So it's not an equals, it's a contains. And so now we know what it's doing. This is going to do the right thing. So then we can run the test properly. Let's go back to here, run the test. This will work. And then we will look at what's wrong. Right, so that worked. Perfect. So now we have a test that will use page objects. It will click and manipulate and interact with the information there. Then it will wait for something to be there. So the test is going to be robust if something takes a little bit longer than it needs to be. And we need to learn how to synchronize in our test. So that's good. But what we've got here is you can see that I don't really need this assertion because I've essentially already asserted it. Because you saw when I was using the wrong expected condition, that when an expected condition fails, when a wait fails, we get a timeout exception, which would fail the test. So I don't really need this assertion to be there in the first place. But when we're testing, it's really important that our tests have assertions. So what can we do here to avoid repeating the assertion in the test? Because I'm essentially having to maintain this in multiple places. So what I'm going to do is rather than wait for the actual text to be present, I'm going to wait until the text is not blank. So what we've got in the expected conditions is we have a not. And this wraps any other expected conditions and says wait until the expected condition is not this. So now this says wait until expected condition is not text to be present, you click the button. Well, what I'm doing is I want to remove the dependency on that text. So I'm saying wait until there's the text to be present in the element is not empty. So wait until there's a value shown, essentially. Let's double check it. So we're waiting until the text in the message is not blank, and that failed for some reason. Okay, so again, this is because our expected condition is a contains. So every string contains an empty string. So what we want is a different expected condition. What we want is text to be. Now, our text to be takes a locator. So what I'm going to say here is rather than get the actual success message element, I'm going to say page.success message, and we'll use the locator. So if I go back into the page here, you can see that I haven't really refactored this. What we have are a lot of, so I essentially think of these as accessors for accessing the web element that is there. We've got a navigator. What we haven't done is separate out any of the locators. So I'll do that now. So this is going to be success message, and it's a constant because it's not really going to change. Let's make it static because then it can be used outside. In order to be used outside, we'll remove the private. Let's make it public. So what have we got? So now we have a constant, which is the locator. So we've pulled out the location strategy into its own abstraction now. I could do this, I probably should do this with the other ones, but I don't need to do that yet. So now we've got get success message, which uses that locator. And in our test itself, we can do page success message, text to be empty. And we're waiting till it is not empty. So let's run this test and it should pass. Now I could create my own expected condition that is more tailored for the functionality, but I'm just using the default ones here just now, and that worked. So what have we got here? Now let's look at this test. So this is synchronizing. It's waiting for the message to change. Then it's asserting what the value of the message has changed to. So we're not repeating the information. So now we have justification as to why we need the asserts and we need the wait. But this is a little bit wordy. So what I'm going to do is I'm going to say page.wait until message shown. Now I'm not saying what the message is. I'm just saying wait until the message is shown because I want to assert on that message. And wait until message shown is essentially going to cover all of that. So here, page, let's move that. Now, I could move this into the constructor on here and have a wait. I could pass in the wait in the constructor if the page needed to be more flexible in how it handles things at different times. I could pass in the wait in here as part of this, but at the moment, that seems okay. At the moment, I'm going for readability rather than extreme maintainability and fitting into the standard for our organization. So our test now should be much more readable. Basically, we click the button, wait until a message is shown, then assert on the message that is there. So I could, in theory, because when I click here, message is shown, message goes away, I could do another wait until message goes away and then assert that there's no text in the success message. But I'm not going to do that just now. I think that's covered in the example in the actual code base because we covered the main things that I really wanted to look at. So let me just recap. Your first test is not a good representation of how we build maintainable and robust automated execution code. This is a much better example. And the reason it's better is that we're using our execution framework to create the dependencies that our actual test needs. Our test is dependent on a driver. Our test is dependent on cleaning up the driver when the test passes or fails. Regardless, that shouldn't be something that the test itself cares about. So our tests have become much, much smaller. In order to make the test more repeatable and easier to create over time, you can see that I've created a page object. I'm going to dive into the page object in just a second to see what we've created. We also created essentially a abstraction for the test environment. So we've got two abstraction levels in here. One that represents the environment run against and one that represents the pages that we're testing. And that's really all a page object is. And a page object doesn't need to be a full page. It could be a component on the page. Typically, if it's a component, you would never have a get method because it's on the page. You just wait for it to be ready. And you have get methods in page objects if it's an actual page. So I want to quickly have a look at this because when I'm looking at page objects, in my head, I tend to split them out. So this for me is the locators. I would normally expect to see a locator section in a page object. So all the bys would probably move up here. Then what we have is our navigator. And very often that might be a separate class depending on how we navigate around the application, or it may not even be present. Then this one, get paratext, I'm going to move that right down the bottom here. So these two, click me button, get success message, I think of these as element accessors. They expose the element on the page, but not necessarily how it is located. So if I just want that element, I can ask the page to give me it, and then I can do low-level work in the test that might not be appropriate or necessary to move into the page itself. You can see I've got a synchronizer or synchronization method, and then we have this, which I think of as a functional helper or a logical utility in the page. And this demonstrates that we might actually start splitting the page object up into more classes. We might choose to have a locator class that just has the locator items. We might choose to have a navigation class, which can be used in different ways. We might sometimes not even expose element accessors and rely on functional helpers. And our page objects might move to be very logical representations of the functionality. So you might have a method called login if it's a login page, but you might not want to put that in a structural page. So you have a separate page object, a logical page object that says like login page with a login method, a structural login page that gives you access to the username and the parameter and the button as element accessors. It varies. So it really depends how your test code grows over time as to what you put in here. But it's also important to understand that these type of methods are doing different things, and you can create rules on your team that say things like, we will never expose web elements into the test. You can do that if you want. That can make your tests very hard to write sometimes, and often puts too much responsibility in your page objects, because every time you want to click something, you need a new method in the page object. Every time you want to get the text that's in an element, you have to create a new method in your page object. You don't need to do that if you pass the web element back. Because remember, the web element is an abstraction. Web element is an abstraction of something on the page. Now, if you are concerned that you might want to swap from WebDriver over to Playwright, and you want to make it easy to migrate your test, so you don't want to expose web elements, which is a WebDriver concept, into your test, then that's a decision you might choose to make. But I probably wouldn't worry about that yet, because at the moment, we've got 2 tests. And so our page objects have to support us in building this up. But what I really want to be important here is that when we are starting with page objects, we don't come in and write page objects and model everything on the page and have a get heading method. I haven't got a get heading method because I haven't used that in a test. That's content. I don't necessarily need to test that content or assert on that content because the user can change that whenever they want. I might want to put in a method that checks, is the heading empty or not? But I haven't got a requirement for that yet. I haven't got a need to do that coverage. We build the page objects to support us in the testing that we're doing, not necessarily the testing that we will do in the future. That concept of you aren't going to need it applies to page objects. So if you hear people say, well, it took me a day and a half to write the page object, they've done something wrong with their process. That day and a half to create the page object should have been a day and a half creating a whole bunch of execution and functional coverage supported by a page object, not the page object itself. So the page object is an abstraction of code that we have created to create functional coverage. And the page object is there to help make it more maintainable and easier to work with longer term. And that is our first test, moving it through from a very basic, horrible, but example, my first test, through to some page objects with synchronization. And it's a much more maintainable and production ready example for how we would use Selenium WebDriver.